Good day, class. Welcome back to Statistics and Mathematics YouTube channel. Please, if you haven't subscribed, kindly subscribe, like, and share so that this video will get to your friends, so that they too will really understand what you are come to treat for today. Today, our main focus will be on multinomial distributions. So in our previous video, we treated something on binomial distributions. Then we learned that for binomial distribution, we just have only two possible outcomes, right? But for multinomial distribution, there are distribution that have trials that result in k greater than two possible outcomes. So here our possible outcomes are greater than two, they are more than two. So when we have an experiment that have such an outcome, we just refer that to be as what multinomial distribution. So for example, a person being interviewed in an option pool to indicate whether they are for, against, or undecisive for a candidate, right? When you see such an example, you see that our interest for the outcome is for, against, or undecisive. So here our possible outcome is what? Greater than what? 2. So here we cannot refer this to be what? A binomial experiment, but rather we refer this to be what? We refer this to be a multinomial experiment, right? So before one can be able to really solve multinomial distribution question, one has to understand the PMF for multinomial distribution question. So before we go that, I want us to check some properties of multinomial distributions before we come to what the PMF. So as I said, these are the probabilities, right? So these are the properties of the multinomial distribution. So the one says that the experiment consists of independent and identical trials. So this is telling us that the occurrence of one trial does not affect the occurrence of the other. So the second one too is just telling us that the addition of all the individual probabilities, that's the P1, P2, P3 up to what Pk. When we sum all these probabilities, it's supposed to give us what? 1, right? And then we have the probability of an outcome in a single trial remains the same from trial to trial. So when we have probability, for instance, what we have here, P1, P2, P3, right? So these probability, individual probabilities that we have, when we move from one trial to another, this probability doesn't change. They always remain constant. And the last one is the random variables are y1, y2, y3, to yk, the number of success in each class of what outcome. So where the summation of yi is equal to that, it's supposed to be equal to. So what you are trying to say that the number of outcome or trial that we have, the y1, the y2, y3, right? Once you sum all these kind of the y's, you have to get what? Our n, right? That's the sample size being selected, right? So let's go to our worksheet so that we can really appreciate the PMF there, right? So this is our worksheet. So for the PMF, we are saying that we are having probability, right? The PMF for the multinomial distribution is equal to n factorial divided by y1 factorial times y2 factorial times y3 factorial to yn factorial, right? Times p raised to the power y1 times p raised to the power y2 times p3 raised to the power y3 times p4 raised to the power y4 to pn raised to the power yn, right? So let's explain the parameters that we see in this PMF, right? So we are saying that the y1, y2, y3 that you see inside, they are all the random variables that we are talking about, right? And then the P1, P2, P3 up to the Pk that you see in each multinomial experiment are all the probabilities. And the n is what we call the sample, right? So that's the sample size. So we are trying to say that when we sum all the y's, that's the random variable, you have to get the sample size, that's what? The n. And then when we sum all the probabilities, as we discussed in the properties, when you sum all the probabilities, you are supposed to get what? 1. Right? So when you sum the probabilities and you are not getting 1, it means that there is a problem somewhere. And then we have the means and variance for the multinomial distribution. So the mean for the multinomial distribution is what? N times what? Pi. And the variance for the multinomial distribution is what? The n times pi times what? Ki. So the pi that we see there is what? Probability of what? Success. Right? So since for multinomial distribution we don't have only 2 outcomes, we have k greater than 2 outcomes, the probability of success that you will get will be more than 2, right? So in case you are finding for the expectation, you are going to find the expectation for the first one, the second one, and the third. That's the reason why you see the PIs there, right? So these are the means and variance for the multinomial distributions. So let's go to work examples. A certain city, example 1 says, a certain city, 3 television station, namely channel 12, 13 and 14. So that these are the channel names, channel 12, 13 and 14. The percentage of audience viewing channel 12, 13 and 14 during prime time on Saturday is 0.50, 0.30 and then 0.2 respectively. If a sample of 8 stations in a city are chosen on Saturday night, find the probability that 5, 2 and 1 will be viewing 12, 13 and 14, and then find the mean and variance of the distribution, right? So we have been given this preamble, right, with a sub question. So we have to deduce. You will see that straightly. You will see that at the end of the day we have given 3 probabilities, which is being assigned to a television station that people view in a certain society, right? So you have channel 12, 13 and 14, and then for channel 12, it's telling us that we are having 0.5 number of people watching. That's the probability. And then channel 13 is having 0.3 and channel 14 is having 0.2. So this is telling us we are having 3 outcomes, which we cannot use binomial to solve, but rather have to use multinomial, right? So we just have our P1 to be 0.5, we have our P2 to be 0.3 and P3 to be 0.2, right? And then our N, right, was given inside the question that if a random sample of 8 stations in the city are chosen on Saturday night, right? So the random sample of 8 television stations is chosen. So here our N will be given as 8, right? And then we have been given a question that 1, find the probability that 5, 2 and 1 will be viewing channel 12, 13 and 14. So right now our Y1, right? Our Y1 and the Y2 and the Y3 has been given here. So here, this one is for our Y1, the 5 is for our Y1, the 2 is for our Y2, and then the 3, the 1 is for our Y3, right? So let's come here, and then yes, I've listed that one here, as you can see here, right? So right now, what you have to do is to write our PMF, right? Just have to write our PMF nicely. That's n factorial divided by y1 factorial times y2 factorial times y3 factorial times all times p1 raised to the power y1 times p2 raised to the power y2 times p3 raised to the power y3, right? So right now we have our p1, p2, p3, we have our n, and then we have our y. So what we have to do is just substitute them inside our PMF, right? N was given as 8, so here will be 8 factorial. Y1 is given as 5 factorial. Y2 is given as 2 factorial. Y3 is given as y1 factorial. So we just multiply that times 0.5, that's the p1 raised to the power y1, which is 5, and then times 0.3 raised to the power 2 times 0.2 raised to the power 1. So once you have this one, right, this whole expression, just punch it inside the calculator, and we are going to get 0.0945 as your final answer. So that's our final answer for the I. And the II is telling us that we should find the mean and variance of the distribution. And then we know that for the mean for our multinomial distribution, we are having n times pi, right? And then we are having 3 p's. We are having 3 p's. That's p1, p2, and then p3, right? So here we are going to find the mean for individual p that we have in our experiment, right? So here we are finding expectation for station 12, right? So for station 12, we are having p1 to be 0.5, and our n was given as 8. So 8 times 0.5 is given as 4, and then we find our variance, right? So once we have our p to be 0.5, if we want to find our q, right, our p is given as 0.5. If we want to find our q is given as 1 minus 0.5, which is given as 0.5, right? So here our q, our variance will given our variance will be given as n times p12 times q12. So here we will be having 8 times 0.5 times 0.5, which is given as 2, right, as we have down there. And then we will find the expectation of channel 13. That one to our p was given as 0.3. So here will give us n times n times p12, which will give us 0.13. So here 8 times 0.3 is giving us 2.4, Then we find our variance. We just subtract 0.3 from what? 1, and we are getting 0.7 here. It will be n times p times q. That will give us 8 times 10, 0.3 times by 0.7. And we are having 1.68. Then we have expectation of 1.4. Sorry, expectation of what? 1.4 is given. Sorry, we find expectation of channel 14, right? And then expectation of channel 14 to be 8 times 0.2, right? And then when you times, you get 0.16. And then the variance will be given as 8 times 0.2 times by 0.8, which will give us 1.218. So basically, this is what the mean and the variance for the question that is given above. We have another question that I would like us to try our hands on, right? So let's go to the second question. So this is the second question. It says a box contains 4 white balls, 3 red balls, and then 3 blue balls, right? A ball is selected at random and it will place each time. Find the probability that if 5 balls are selected, 2 are white, 2 are red, and 1 is blue. So we have this question, right? So we see that the individual probabilities were not given to us, right? So we have to find the individual probabilities ourselves. So when we look inside the box, we're having a total of what? 4 white balls, 3 red balls, and then 3 blue balls, right? So our n is equal to 4 plus 3 plus 3, which will give us what? 10, as you can see, right? And then that's the total for the balls inside the box. For us to get a white ball, that's for the P1, it's going to be the total white balls divided by, the 4 white ball divided by the total white ball, which give us 4 divided by 10, which will give us 0.4. And then for the P2 will give us 3 red balls divided by the total balls, which will give us 3 divided by 10, which is 0.3. And then the P3 will give us the P3 will be the 3 blue balls that we have. So that will be 3 divided by 10, which is equal to 0.3. So here, and then our y's was given here inside the question. That one is what? 2 for the white, 2 for the red, and 1 for the blue, right? As you can see nicely here. And for us to get the n, you see that we just said that summation of the y's. So here we have 3 y's, right? y1 plus y2 plus y1 is equal to what? Our n, right? From the probability that we just read, right? So here will be 2 plus 2 plus 1, which is give us what? 5. That's the same random selection that was made from the box, right? We were told that the probabilities that if 5 balls are selected at random, so they choose 5 balls from the box. So here our n is giving us what? 5, right? So here we have n factorial divided by y1 factorial times y2 factorial times y3 factorial, all times p1 raised to the power y1 times p2 raised to the power y2 times p3 raised to the power y3. Once we have this one, we just point this one, the whole of this one inside the calculator, then we get your final answer to be 0.129. So basically, this is what I want us to learn for today for the multinomial distributions. So in our next video, we are going to treat more on hypergeometric, geometric distribution, negative binomial, and Poisson distribution, so that at the end of the day you will be more equipped with probability distributions. Take your time and then watch the video again. If you haven't subscribed, kindly subscribe, like, and share so that this video will go viral for others to also get in touch with the video. Bye. Have a nice day.